Okay, good morning, everybody. Yesterday we started with pneumatic systems. We saw the basic elements in pneumatic systems, and in those elements we had compressors, and then different types of compressors we saw. Then we started off with the receiver. Receiver, as you can see on the screen, we have this is also called as a pressure vessel. While studying design engineering, you must have studied design of pressure vessels. The pressure vessel, it has got the pressure gauge. It is actually a thick cylinder capable of sustaining high pressures. So pressure sensor would be there, or pressure indicator would be there, temperature indicator would be there. There will be some safety valve and vent, and then you have a drain for draining out the air or cleaning the thick cylinder, so to say. And then you have the discharge valve coming out of the receiver or the reservoir or accumulator, whatever you call it as. So this receiver collects and stores the air from the compressor. We are not getting into the design part of it. Only thing is that what is the utility of receiver we want to know. Then you have an important element called as air dryer. The compression process produces a lot of water because of compression, which is forced out of the compressed air. The water must be removed using a dryer. Now there are different types of dryers which are essential in use for pneumatic circuits, because this compressed air will be doing some work through cylinders. It will be passing through the pipeline, it will be passing through different valves, and then it will be moving to the cylinders, pneumatic cylinders. So there water content is not advisable. That might erode and rust your components. So water must be removed, and this work is done by air dryer. Then we have the piping network from the compressor. Then this is used for connecting. You have the pneumatic power supply remotely placed, and then in a typical industrial environment, if you can try to visualize, you have big air compressors placed somewhere near your utilities section, where there will be electrical generator plus air compressor plus hydraulic power pack. All these elements would be there in one corner of your industrial premises, and then by using pipelines, those are given to your workplaces, maybe workshops, maybe press shops, maybe assembly shops. So this piping network design is also a big field in itself. So we have the air distribution provided by using piping. These are provided with some valves, flow control valves, accumulators. Then you have pressure control valves, those are used, and then you have a typical distribution system. As this is a sketch of a compressor, reciprocating compressor, the compressed air going to the accumulator or receiver. And then if we don't use the receiver, what would be the problem? You might get a fluctuating air supply, isn't it? When the compression stroke is there, that discharge pressure, that will be a pulsating airflow. We want a stabilized airflow. So this receiver works also as accumulator or stabilizer, so to say. Then from there it goes through a dryer and then through piping network. And this drain is meant for removing the water that is accumulated in the compressed air. Then different types of valves, we have to be a bit attentive. You have the cylinders, you have different types of valves, which we'll be seeing in details in the coming slides. In a typical pneumatic circuit, actuating devices can be linear or rotary. Rotary actuators are called as air motors. We are talking about pneumatic circuits. And then linear actuating devices are pneumatic cylinders. And the valves those we use, what they can do, they can condition, they can regulate, they can restrict the flow, they can direct the flow, then they decide. That means they can work as logic control also. They can work as a directional control valve. They work as check valves or restricting valve. They can work as a regulatory valve. They can condition. So conditioning valves are also there used in pneumatic circuits. So it's a typical pneumatic circuit. As you can see, the circuit extends both the cylinders in a sequence. When the two push button switches are pressed together, the cylinders will stop when the stop push button alone is pressed. This we'll see later on. This is just to give you a feel of a pneumatic circuit. Now these pneumatic circuits, these are the schematics of pneumatic circuits. Please be attentive. we'll see the circuit design later on, just to have. So these are the two push buttons, start and regulatory button, shown in the red square bracket. So this is your control panel, so to say, and all these piping and valves will be there near your actual system. Maybe a pneumatic press is there, pneumatic hammer is there, wherever. So this will be essentially your control panel, so to say. As you can see, this is your control panel. All the push buttons are seen. Then you have directional control valves. Then you have flow control valves. You have spring actuated direction control valve. Then you have limit switch actuated directional control valve. And then pressure relief valve we have. And this check valve, one directional valve. You have a restrictor. So these things we'll see in details. This is how we draw the pneumatic circuit. This is the conditioning part. You have a lubricator, pressure controller, and filter. This is your compressor. The compressed air starts from here. You have the pressure regulator. You have pressure regulator. Then you have pressure control valve, pressure relief valve, then filter, dryer, and then that conditioned air goes to your pilot operated or push button type control valve, and from there it goes to two circuits separately. This is one circuit. This is first hydraulic cylinder. This is first pneumatic cylinder. This is second pneumatic cylinder. Now, more or less, the pneumatic circuitry and hydraulic circuitry are similar. Only the valves would be different. And what is the essential difference you feel? Normally, in directional control valves, pneumatic control circuitries, you'll find that the outlet valves are exhausted, or the air after doing work is exhausted to atmosphere. Whereas in hydraulic circuitry, that oil cannot be exhausted to atmosphere. It is to be recycled. So it is connected to your hydraulic accumulator. So this is the essential difference between pneumatic circuit and hydraulic circuitry. The exhaust air is exhausted to the atmosphere, whereas in hydraulic circuitry, the exhaust oil or the outlet oil is accumulated. It is not vented to the atmosphere. This is the essential difference. Then we have different components. We'll see these in details. The previous circuit contains a filter, regulator, lubricator, FRL unit, filter, lubricator, and regulator and lubricator unit. Yeah. This is the, as I told you, this is the FRL unit, filter, lubricator, and dryer, and regulator unit. Okay. So then we have, which is connected to the mains air supply from the compressor. We have seen. Logic valves decide when the operation begins. Now these are pneumatic logic valves. Remember, these are not electronic logic valves. Control valves direct the air. And then restrictors control the speed of the cylinders. How do they control the speed of the cylinder? By controlling the flow rate of the air. The following slides show some common pneumatic devices and their symbols as used on engineering drawings. These you need to remember, friends. So this is a 2x2 directional control valve. Now what this nomenclature indicates? Remember very clearly. So this is 2-port and 2-way or 2 position. Now the position of these directional control valves will be only 2 positions. So this second two corresponds to position or 2 ways, and first 2 corresponds to number of ports. So first digit corresponds to number of ports and second digit corresponds to number of ways or number of positions. What are these positions? Slider positions. When the so if you look at this sketch, this is a 2x2 means what? You have how many ports? 1 port and second port. 1 port and second port. So 2 ports. And how many are the positions? This is the flow allowed position and this is flow blocked position. So this can be moved. This can be aligned as per my requirement. So this is 2-port, 2-position directional control valve. It is also called as 2x2 valve. Similarly, I can have 3x2 valve. I can have 5x2 valve as per my requirements. 5x2 valve, what does it mean? 5 corresponds to number of ports on the directional control valve, and second to 5x2, 2 corresponds to number of positions of the directional control valve. 2 position and 5 ports. First digit corresponds to ports. If you have 4 by 2, you have number of ports is equal to 4 and number of positions is equal to 2. How the symbol works, consider the animation. Air is initially blocked from passing through the wall, as you can see. See, this is the first position. Device actuated. Now this actuation of device can be by using a pilot valve, can by using a lever, or some pilot pressure is also applied. So there can be one more pneumatic supply will push or pull this directional control valve. So device actuated. So this is a 2 by 2 valve. So one inlet and one discharge. So 2 ports and 2 positions. So 2 by 2 valve. Device actuated. Air in and air out. This is one position. Now, air is now allowed through the valve to the output. And second, okay, the second position, you can see what will happen. See the second position. Okay, this will be pushed. Well, it is not, animation is not working. In the second position, what will happen? This valve will be pulled so that this will be aligned with my supplier. So what will happen? The airflow will be blocked. Okay. The 3 by 2 directional control are normally closed. Normally closed. This is normally closed. This is the supplier and this is the exhaust. Okay. This is the supplier and this is discharge. Okay. So this is normally closed. 3 by 2. Why 3 by 2? 1, 2, and 3. Number of ports is equal to 1, 2, and 3. And what are the positions? 2 positions. So this is 3 ports, 2 position, 3 by 2 directional control valve, which is normally closed. And when it is actuated, when this is pushed, then this will be aligned here and the supply air will flow to the outlet. 3 by 2 valve allows the exhaust air to vent to atmosphere in the off position. This is normally closed. 3 by 2 directional control valve normally open. So this is a normally open NO and that is called as NC. Normally closed is NC and normally open is NO. So what will happen here? Normally open. So this is the position 3 by 2, 1, 2, 3 ports. So normally open, the air is coming from supply and going to the discharge and going to my device. Okay. So this is normally open. And when this is actuated, this will be aligned here and the flow will be blocked. Okay. So we'll move further. 5 by 2 directional control valve. What is important? Normally used with double acting cylinders. 5 by 2. 5 port valve switches the 2 output ports from exhaust pressure to pressure exhaust. Normally used with double acting cylinders. So why this is 5 port 2 position? 2 positions, as you can see, 2 positions. This is the original position. And why 5? 5 ports. 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5. So 5 port and 2 positions. And this is normally open, as you can see. So the supply air will go to the cylinder, one side of the cylinder, forward stroke maybe. And when this is pushed, when this is actuated, what will happen? This will be aligned here. So this will be aligned here. So the flow will go to the other end of the cylinder. And then the cylinder will be pushed back. So this is a double acting cylinder. And then what will happen? This port, discharge port, will be aligned here, isn't it? And then it will go to exhaust. Okay, this will be exhausted. So inlet originally and then exhausted. And when this is aligned, inlet will go to here, inlet will go here, and backward stroke, and then exhaust will be aligned here. Exhaust will be aligned here. Okay. Exhaust will be aligned here. This is the 5 by 2 directional control valve. Now inside the 5 by 2 valve, just to know the working, 5 by 2, 5 ports, 1, 2, 3, 4, 5. So this is the pilot operation valve. Okay, this is also called a spool. How to move this spool when I want to change the position? So for that, the hydraulic or pneumatic supply is provided here just to actuate this valve. In this position, the pressure is allowed from P to B. In this position, the pressure is allowed from P to B. Exhaust from A to S. This is inside of the 5 by 2 valve. And then when this is pushed like this, when this is pushed, this pilot operated or manually operated, lever operated, or sometimes it is solenoid operated also. So these valves can be operated in number of ways. Now, in this position, the pressure is allowed from P to A. Pressure is allowed from P to A. Here it was P to B, now it is P to A. Exhaust from B to R. Exhaust from B to R. Okay, this is how the 5x2 spool operation animation shows the spool operating when each pilot is operated. This animation, I don't know if it is working or not. Okay, this is P to B and this is P to A. Now the cylinder, this is known as a linear actuator. This is the component that provides the movement to achieve the machine operation. Okay, so double acting cylinder, ports, supply port, discharge port. This will become in reverse stroke. It will become supply port. This will become discharge port. What this arrow means? This is controlled cushioning effect. Controlled cushioning. So I'll be having one more unit here where I'll be bleeding up some of the air, or I'll be bleeding up some of the hydraulic oil, so that when it reverses back, it does not ram on the body of the cylinder. It will have a cushioning or shock absorbing effect. So controlled cushioning is shown by this symbol. The symbols you can see cushion operation. See, you have the orifice, a throttle, so to say. When the backward stroke is there, the air or fluid leaks out, and while reversing, it will have a smooth cushioning operation in both the strokes. So this is cushion operation. 5x2 operation animation shows the operation of 5x2 directional control valve when connected to differential cylinders. Okay. This position, the pressure is connected. See, what is happening? The supplier, 5 ports, 5x2 valve operation, 1, 2, 3, 4, 5. Initially, backward stroke, exhaust is going to the atmosphere, and when I actuate this, when this is aligned here, what will happen? When the device is activated, pressure is switched to the back of the cylinder, which now extends. When back of the cylinder, this bar or this piston rod extends. Note that in both the position, air must be able to escape via exhaust ports. Okay, these are the exhaust ports. Okay, so this is how. Second case, when this is aligned here, the supply will go to the forward part, the front part of the cylinder, and then I'll have backward port, and the exhaust port there will be exhausted. 2 pressure valves. So this is called as AND gate, logic gate. 2 pressure valves. An output is achieved when input 1 and input 2 are activated. When input 1 and input 2 are activated, I'll be getting some output. This is the symbolic representation of pneumatic AND gate. 2 pressure valve. Shuttle valve provides me OR gate. In pneumatic system, shuttle valve provides me OR gate. And output is achieved when input 1 or input 2 are activated. Input 1 or input 2. Input 1 or input 2 are activated, I'll be getting some output. So this is achieved by using a shuttle valve. So remember, right? Shuttle valve provides me OR logic operation. Pressure regulator valve with relief port. This is the symbol. The output pressure is regulated by the spring pressure. Okay. We'll see the pressure regulator sketch, schematic sketch. This is a symbolic sketch. And then I have inside the regulator. See, be attentive. This is spring operated. So the pressure is regulated by using a spring of appropriate stiffness. I can preset the stiffness. So the pressure, this is the supply and this is the exhaust. Now, when the supply pressure, when I have higher pressure, let us say, what will happen? This will be pushed down against this plane and I can preset it. The pre-tension or pre-compression of the spring can be set by rotating the screw. So accordingly, it will supply. The input pressure is allowed through the normally open valve. So initially this is open. Okay, initially this is open. Okay, it will be lifted up and I have the supply coming in. Okay, output pressure acts on the diaphragm against the spring. So on this diaphragm, the output pressure is acting. And this force, whatever is the pressure acting above the diaphragm, it will generate some pressure force. And this force will be balanced by my stiffness force. Whatever spring I have, K into X, displacement of the spring or deflection of the spring, will provide me the spring force. That will be balanced. And that will be balanced until the balance is there, the flow is allowed. And if the balance is lost, if it is If the pressure is less, it will be lifted up. If pressure is more, it will be pushed down. When the output pressure is greater than the spring force, the valve closes. Output pressure acts on the diaphragm. When the output pressure is greater than the spring force, when the output pressure is greater than the spring force, the valve closes. The regulator in action, you can see. See, it has moved down now. Okay, it is moves down. So it is exhausted. When the output pressure is more, when the pressure is more, what will happen? Through this port or through this port, it will be exhausted. So if you go to a typical industrial environment, this regulator will always be in operation. So they will continuously listen to that hissing sound. So that happens when there are pressure fluctuations. When the pressure rises, this will be venting out the excessive air, and so that the desired pressure is maintained. And when the pressure is as per my requirement, what is my requirement? And this spring will be exerting the pressure force or the stiffness force as per my requirement. And when this is closed, when this is lifted up, this valve will be closed, and I'll be having the exhaust will be closed, and I'll be having the air supply going through my required discharge valve. Okay, this is a closed valve. Regulator in action, different positions are given. Now filter is used to remove small particles. Filter is used to remove small particles from the air. If the particles are left in the air, they will cause the pneumatic components to stick. This is a symbolic representation of filter. Inside the filter, you can go through this. The lubricator puts a mist of oil into the air. Now, if you remember in two-stroke engines earlier, there used to be petrol type of lubrication. We used to mix petrol with oil or oil with petrol, small amount of oil, so that when the combustion occurs, the oil traces will lubricate the piston rings or piston valves or cylinder valves. So similarly, we add mist of oil into the air so that this lubricates the internal components of the pneumatic valves and the cylinder. And inside the lubricator, then restrictions, different types of restricting valves. Restrictions are used to control the airflow to pneumatic devices. The speed of the pneumatic devices will therefore be controlled. This is the symbolic representation of restriction. Non-written valves. Check valves are used to allow air in one direction only. So these are non-written valves. So when the air is supplied from the air, so this valve will be pushed, and only then air will be passing. So this valve, ball valve or check valve, these are called as non-written valve. And from this end, you will not be having any supply. So one-way valve also you can call. So the check valves are used to allow air in one direction only. So these are the non-written valves. Flow control with check valve, this is a symbolic representation. So restrictor plus check valve. By combining the restrictor and check valve, the air is restricted in one direction only inside the restrictor and check valve. So the valve actuators, many valves are actuated by some mechanical or electrical method. Below are some common actuation symbols. We are talking about the actuation of the directional control valve itself. Either we can do it by using a lever, by using a push button. By using a push button, this is a symbolic representation of push button. You have a hand lever. You have a pilot pressure. There will be some additional pressure which will be, this is called as pilot operated valve. Then you have solenoid or electromagnet. Solenoid operated valve is also there. The valve actuation is also there. Pilot or solenoid. So solenoid, this is the symbolic representation. It will be one rectangle with a cross line. Pilot, you have a triangular symbol. And then pilot or solenoid. So this is symbol is for pilot and this is for solenoid. Pilot or solenoid. Pilot and solenoid. So we'll be having symbol in symbol. So triangle plus this cross line. So pilot and solenoid. Pilot spring operation on a 5x2 valve. Before the button is pressed, the spring holds the spool valve. When the button is pressed, the button force overcomes the spring force and the valve switches position. When this button is pressed, this will be doing work against the spring force and this will be pushed further. So this is the button pushed and this should change the position. 5 port 2 position. Simple circuit operation, friends. See, this is the 1, 2, 3, 4, 5 by 2 directional control valve. you have controlled cushioning, double acting cylinder flow like this. So this is a limit switch operated. This is a roller operated the directional control valve. Okay, when this is touching here, it will be pressed, and then I can bring in the different circuit into actuation. As you can see the arrow. So accordingly, I can actuate this valve based on the limit switch positions. So this dead end, one position of the limit switch, wherein the limit switch or roller switch will actuate the directional control valve. When it reaches this position, this roller will be actuated by using the second limit. This we'll see in details later on. These are the two positions. See, this is the extreme retracted position, and this is the extended position. Limit switch actuated. This we'll see in details later on. Okay. I think, friends, we'll stop. The second lecture must be